Today we'll be focusing on calculations in GIS, but we'll be mainly focusing on calculations. So we know that we do calculations in Mapwork so that we can know the real-life distance between 2 points in a map using the scale given, since we know that a map is just a projection of the actual ground. So we'll be focusing on 4 calculations today. One, which is distance, area, gradients, and magnetic declination. So we will start off with before we get into the Mapwork, let's start by our conversions, knowing that we have 2 different types of maps that we work on, and these 2 types of map have different scales and their conversions are also not similar. So firstly, we have the topographical map. The topographical map uses a scale of 1 centimeter, actually represents 50,000 centimeters in real life. And if we want our answers to be in kilometers, we will multiply by 0.5. And if we want our answers to be in meters when we're using the topographical map, we will multiply our answer by 500. Then we have the orthophoto map that uses the scale that 1 centimeter on the map actually represents 10,000 centimeters on actual ground. If we want our answers to be in kilometers, we will multiply whatever answer that we get by 0.1. And if we want our answers to be in meters, we will actually multiply by 100. So our first calculation, it is distance. Distance, it is the actual distance between 2 points, and the distance uses the formula that map distance times scale difference. The scale difference will be according to the map that we will use. So let's do it practically. Let's calculate the straight line distance in meters from point P to Q using our topographical map. Then you place your ruler using the centimeter side to measure. So, since we know that the formula for distance, it is distance equals map distance, which we'll get by measuring times map scale. So, since we had measured from the map distance from point P to Q. So we measured and we found out that our map distance, it is 1.6 centimeters. Since we're using a topographical map, we will times by 500, so we can be able to get our meters, which we got 800 meters. That is our answer. Now, let's say we want to convert this into kilometers. So what we'll take our map distance, which was the 1.6 centimeters, and multiply it by 0.5, which will give us 0.8 kilometers. On to area. Area uses the formula length times breadth. All the time when we calculate area, we must know that our final answer, we use the units kilometers squared, meters squared, centimeters squared. Now, we also need to know that when we calculate area, we have length times width or breadth. Length is the longer side of the shape and width is always the shorter side of the shape. No matter how your shape seems, length will always be the longer side of the shape. Now we are going to calculate the area of the demarcated area on our topographical map. We start by measuring our length and then we measure our width or breadth. Since we know that our formula for area, it is length times breadth or length times width. So the first thing that we will do, it is to find out our length. Since we had measured on our topographic map, we found out that our length is 1.6 centimeters. Since we want our answers to be in kilometers, we will multiply by 0.5 so we can get 0.8 kilometers. That is our length. Then we will move on to our breadth or width. We measured our breadth or width to be 0.7 centimeters on our map. We will multiply it by 0.5 so we can transform it into kilometers, which is equals to 0.35 kilometers. Then since we have found out both our units and transformed them into kilometers, we can now apply the length times breadth formula of the area. So our length, it is 0.8 kilometers multiplied by our breadth, which is 0.35 kilometers. Now since we are both kilometers, it means that our answer will be obviously in kilometers squared, since we are using the same units. So our final answer, it is 0.28 kilometers squared. On to gradients. Gradients, it is the height and distance between 2 points on our map. To calculate gradients, we need to only follow just these 5 easy steps or 6 easy steps, whereby step 1, we will calculate the difference in heights by subtracting the lowest heights from the highest heights. Our answer must always be in meters. Then step 2, we will measure the distance in centimeters using our rulers, of course, on the map that will be given. Then with step 3, we will convert whatever answer we got in step 2 to meters, and then that answer we will multiply it by 500 if we were using a topographical map, or if we were using an orthophoto map, we will multiply that answer by 100. Then we will write these two answers as ratios, and then step 5, we will cross multiply these ratios so that we can get an answer or a ratio. We know that the ratio we will get to to the second relative number will always be 1:2. Our gradient was always written as a ratio. Now let's put this into practice by calculating the gradient between Sport Heights 248 in block A8 and Trick Beacon 135 in block C7 on our topographical map. You will place your ruler in centimeters from Sport Heights 288 to Trick Beacon 135. Since we know that the formula for gradients, it is gradient equals height over distance. Since our first step is to calculate the difference in height by subtracting the lowest from the highest. So we will subtract 324,4 minus 248, which will obviously give us 776,4 meters. We said that our answer must always be in meters. Then we'll move on to our second step, which is what we did first, which was calculate our distance, the actual distance on the map in centimeters, and we found out that our answer is 3,5 centimeters. So we know that after finding out, we have to convert it into meters, and that means that we must multiply by 500 since we're using a topographical map, which gives us 1,750 meters in total. And then we will move on to the next step, whereby we will put both these sides into ratios. Since we are putting both units, we are going to say 1,750 over 1,750. The other side of the ratio will be 1,750 over 76,4 meters, of course. Then we will cross multiply so we can get a good ratio. Then we know that 1,750 divided by 1,750, it is equivalent to 1. Then 1,750 divided by 76,4, it is equivalent to 22,9. So that is how we get gradient. Then we have magnetic declination. Magnetic declination is the angle formed between true north and magnetic north measured in degrees. Now we always found our magnetic declination on the lower side of our map or on the upper right hand side of our map. The magnetic declination contains the west of true north when the map was taken and its mean annual change, and which direction the mean annual change is going to, eastwards or westwards. Usually, since we are in South Africa, South African maps usually move westwards all the time. When calculating magnetic declination, we only use 4 steps. Step 1, we will calculate the difference in years between the current year we are given in our instruction or in our paper and the year in the map which the magnetic declination was taken. Then step 2, we will multiply the number of years with the mean annual change that we are given in the map. Step 3, if the mean annual change is eastwards, then you have to subtract the change from the magnetic declination given. If the mean annual change is westwards, then you must add it to the given magnetic declination. Step 4, the units of the magnetic declination is always west of true north, even if the annual change is eastwards, which means that eastwards we have to subtract, but our magnetic declination will always be west of true north. Now let's calculate the magnetic declination for 2026. This is the magnetic declination that we will be using to calculate the new magnetic declination for 2026. So we know that the mean magnetic declination, it is 19 degrees 23 minutes west, and the map was written in 2019 doesn't matter the month or the date. And then we know that the mean annual change, it is 10 minutes westwards. Okay, since we know that our formula for magnetic declination follows just about a few steps. So the first step, it is us calculating the difference in years between the current year given and the year in the map. And we were given 2026. So it will be 2026 minus 2019, which was equal to 7 years difference between these 2 years. Then our second step, whereby we will multiply the number of years with our mean annual change. And we had seen that our mean annual change was 10 minutes westwards. So it will be our 7 years multiplied by 10 minutes westwards, which will give us 70 minutes westwards. And then our next step will be to add the answer we had got from multiplying the number of years and mean annual change. So we know that we have 19 degrees 23 minutes westwards. So now we have to add this with the 70 minutes westwards, which we had gotten from multiplying the annual change with the difference in the number of years. So now we will add minutes with minutes, which makes us get 19 degrees 93 minutes westwards of true north. So now we know that the minutes always have to be about 60 minutes and below, which means that we will take the 60 minutes and add it to the 19 degrees, which means that it is 1 minute. So obviously our answer will change into 20 degrees 33 minutes west of true north. And that is how we calculate the magnetic declination. This is the magnetic declination for the year 2026.